So this is the first part of chapter 2. And like I said, I want you to get a grip on the size of rational numbers. How big are they? How small are they? Get used to this. When you look at them, they mean more to you than they did before. So a couple things I'd like you to realize about rational numbers. A root word here of rational numbers is ratio. So this is a rational number is often a ratio. And so ratios can be written in two different forms. You need to be able to recognize rational numbers, ratios, in terms of fraction form, and also in decimal form. Okay, so we got fraction form and decimal form, and we want you to be able to recognize those and kind of play with them. So a fraction form would be like 3/4, and a decimal form, 0.75. So as I go through this, I'm going to give you little hints and little guides about some standards. And one of them right away here is I say decimal form. You should never write a decimal, never leave a naked decimal, we call it. Never leave a naked decimal. Always sandwich it between two numbers. So don't write this as 0.75. Okay? That's called a naked decimal. Math rules universally are do not leave a naked decimal. So don't do this. Always put a little 0 in front or even a 0 after if you want to focus on the decimal. Okay? I want you to realize that every number, whether it's written or not, like whole numbers up to this point, if we had 6, for example, 6 does have a decimal there. It's often unwritten, but there's a decimal kind of stated at the end. Now, if you want people to focus on that decimal, and as you take higher sciences and so on, when you're measuring things, and you want them to know that you were careful about it being exactly 6, you would need to put 6.0. So never leave a decimal hanging at the end, and never lead with one. Never leave it naked. Okay? So no naked decimals. You must sandwich it. Okay? Just a little rule about decimals. You should also realize a fraction is made up of a numerator. That's the number on top, over top of a denominator on the bottom. So just to use those words, we talk about that number on top. We say numerator and a denominator. And one thing about a numerator is it must never equal, right? Equal with a slash through it. It must never equal 0. A numerator cannot equal 0. Okay? And I like to try to stay as quick and as brief as I can in these lectures, but sometimes to illustrate why that works. If you think back to other years, I think you probably realize that 8 divided, or 8 times, we'll just start with the time side of this, 8 times 2 equals 16. And I think you probably realize then that 16 divided by this number equals this one. We can always reverse to check. Or we could even say 16 divided by 8 is going to equal 2. You can always reverse it to double check. But look at the situation when we have a 0. If we go 8 times 0 equals 0, that's true. But to go in reverse, right? And to reverse this trend, 0 divided by 0 does not produce 8. We cannot divide something by 0. And this little line here on a fraction means divided by. So in our ratio, it kind of means compared to, it means divided by. So the denominator cannot be 0. This doesn't work. You try it in your calculator, and it'll spit out a little E, probably, for error. Okay? So a couple things maybe you didn't realize about ratios. We need to be able to, in 2.1, one of these TSWs, one thing you need to be able to do after playing with these rational numbers is order rational numbers. Doesn't mean go to McDonald's and get a side order of rational numbers. It means you must organize them from smallest to largest, or vice versa. Put them in order. Which one's bigger and which one's smaller? Do you know them well enough to organize them? So I want to just use a common thing to help you put them in place is this idea of a number line. So if you just draw a quick number line and try to get used to drawing one, just throw 0 in the middle and then try to divide it up equally. So we got 1, 2, -1, -2. And it keeps going on in this direction smaller. And in this direction here. Okay, keeps getting larger. Now if we were to place a couple of numbers on here, if we had, say, numbers 1.5, numbers -2/3, we had numbers -2.25, we had 0.7, okay, one more, -3/4. Cool? Okay. If we had these 5 numbers and we had to kind of order them, a number line is a helpful way for us to kind of place them in a spot and see that in our mind. So I want to encourage you to use a number line as a tool to keep your facts straight. A number line is a tool to kind of make this easier. So does someone want to come up here and place these on this number line? Okay, go ahead, Blaine. With this blue marker, then let me just number these. I'll number these with maybe a green marker. No, go ahead and just write the actual number on. So using a black marker,
Write the actual number.
just put a little dot on the line where you think those are, and then just number it. Be gracious as he writes on here. These boards are not. Can you put a little tick on the number line where you think that is, just like I did with the 2 here and the 1? There you go. Beautiful. And I like how you put it above, too. It's easy to see. So that's 1.5. Good. A little bit more than half, 0.7. One more, and I want you to come sit up here, and then you can go down and learn it by yourself if you can't stay here. Okay? Good, Blaine, you're doing well.
I'm talking about it with Matt. It's about that. I'm not joking.
Eli, stop talking. I'm not even talking first. Eli, sorry.
Yeah, you just have to put your pen on that board and, and just draw it with confidence and just write on it, and it gets better with practice. Okay, thank you.
Good job, Blaine.
So, if you look at this, it's not easy to write on this board, but using a number line will help you organize it. So if on a quiz or so I say, take these 5 numbers and organize it, perhaps you'll just write a number line, and you'll see a place where it puts in. Anybody have any questions on this? Okay, I hope you can use number lines effectively.
Number line
If
through.
I gave you a bunch of numbers, and I'll just write down a fairly easy set to start with. If we had the numbers 3/8 and 1/2, 9/16 and 3/4 and
Oh, we're supposed to be writing this down?
7/8. If we had these 5 numbers, and I asked you to organize them from smallest to largest. Okay, so if you went from smallest to largest, one technique to do that, so we'll just call it method number 1, is to sit here and to make them all use a common denominator. If we put them all over the same denominator, it will be easier to organize them. So you need to know this little trick. Does anybody know what, as you're looking at these, what is a common denominator to all 5 of those? Is that 16? That's right. And I chose some that are, I think, fairly easy to recognize that. Sometimes it's hard to. So sometimes this common denominator trick will be very easy. But let's do a little practice here. Yeah, Eli?
How do you remember how to spell all of the confusing math words?
I don't know, spelling's never been an issue for me.
Because he went to Harvard.
Okay.
No, he didn't.
Okay. Shh. If we have 3/8, how do we write an equivalent fraction, something that's equal, an equivalent fraction where our denominator is now 16? How do we find one? Yeah, Riley?
If you double the bottom, you have to double the top.
Nice. I like your language, right? What you do to the denominator, you have to do to the numerator, and vice versa. Right? The golden rule of fractions: if we double the bottom, we must double the top. Okay? And so, I hope you can realize that we multiplied 8 by 2 to get to 16. We must also do the top, and so 6/16 is an equivalent fraction to 3/8.
Wouldn't it be easier to like say plus 3 or plus 8 and plus the same number?
No, because,
You do.
okay, well, this case, because we doubled it, but watch on the next one, okay? Be careful of, make sure you're making, you're right, recognizing a pattern, and you're true, but that's because we doubled it. But watch this next one. If we had a half, what does a half equal over 16? Someone else, you can raise your hand, yeah?
8.
Okay, and that's, okay, so we multiplied this by 8, so we must multiply the top by 8 as well. And so we end up with our 8 over 16. Okay, and if we keep doing that for all of these, 7/8 equals, I don't want to put the little box in the bottom. Over 16, Morgan, what's 7/8 an equivalent fraction to that over 16? 14 then, right?
I knew that one.
Good.
I know it.
So 7/8, 9/16 is already over 16. So we've got our 9/16. I'm just kind of putting a little highlight around each of these each of these top parts here. And how about our last one here, 3/4? Zach McGinley over there, how can we put 3/4, an equivalent fraction to that over 16? Good. So we multiply it by 4, and we multiply it by 4, so we end up with 12. And now, if you look, they all have a denominator of 16. We should be able to quite quickly organize them from smallest to largest. So if we're going to put them on our little smallest to largest scale here, Eli, Warren, could you help me? Which one of these?
I don't think I can.
Now, oh, look, I think you can. If we look at, these are all over 16, so which is the smallest out of 16? Just let Eli think through it. Yeah? Sure, 6 out of 16 is the smallest, so, and that fraction was 3/8. So that's going to be our smallest one. So we'll put that on the smallest side. What's our next one, Eli?
Oh, what? 12 out of 16?
Which one?
12 out of 16?
Have a look. There's,
Oh, I can't see.
okay,
And it's 8 and 9 and 12 and 14.
nice. And so it's pretty easy once we've got them over a same denominator. So this one here, the next one up then is a half. And then 9/16 was just straight up, we didn't convert that. And then the 12 was 3/4. And then the 14 was 7/8. So by putting them all over a common denominator, that's a tool to help us organize them straight. When you get better at fractions, especially if you're a carpenter, because we often use these types, even 1/16 of an inch. Cut that board to 72 and 15/16 of an inch, so it's a nice tight joint. You hear carpenters call out these kind of measurements, so you get really quick at reading measuring tapes and learning these numbers, especially to the 16th. My brother is a finishing carpenter, he does kitchens. He doesn't want even a crack between countertops and stuff when they join. So he's measuring to 32nds or even 64ths of an inch as he's measuring, drawing a line and cutting it so it fits in there flush, right tight. So there's no crack at all between those boards. Okay? So you get used to fractions, especially when you're working in retail. So much of a dollar, half a dollar. Selling gas, it's always a certain amount of cents, and so on. So you get really good at dealing with rational numbers. Okay? So another method too, I think a lot of you will find easier, but you need to know both methods, is convert to a decimal. If you convert it to a decimal, so if we take a bunch of numbers, if we had 3/5, 2/8, 1/4, 9/16, and 3/14. Here, I think you'd have a much harder time trying to find a common denominator. So Nigel, do you have a calculator? Could you pull out your calculators? Let's convert these fractions to decimal form and look how this would make it easier. So if I could have someone convert the first one, and then if you could just raise your hand, I'll call on you. You got the first one, Blaine? What's 3/5?
0.6.
Okay, good. And I like how you said that. No naked decimals. So 0.6. What's the next one, Adrian?
How is that?
I hope you can.
I'm just wondering.
I hope you can do this, Adrian, without a calculator even, right? 2/8 is 1/4. Pardon? 0.25.
Mr. Eagles, how do you do this?
Okay, good question. I was maybe assuming. This line here means divided by. So you go 2 divided by 8. And you will end up with the decimal.
That's 70.
2 divided by 8.
It's actually It's 70.27.5.
Okay, try to hit clear on your calculator and do that again. 2 divided by 8, careful Brian,
Divided by 8
equals
equals
0.25. You must have hit a wrong button or had some other numbers alive in your calculator.
Eli, do you know what
Riley?
the divide button is?
Yeah, I do.
0.25?
Eli, do you know what the divide button is?
It's the one with the dot, line, dot.
So this one here, 1/4, is also 0.25. And here, at 9/16, anybody got that? I don't know this one off my top of my head. Eli, you got that?
Decimal 56.
Good job.
Yeah?
Decimal 56.25.
You know what person you have to put the exact number?
Yes.
Absolutely. Unless they tell you to round it off, I want you to fill out the numbers on the screen of your
When it,
calculator.
like, popped up, it's like, and it says error.
Unless they told
Usually it goes
you,
up to 5.
Oh.
unless they told you to round off, you use your full calculator screen. How about the last one, 3/14? Eli?
Okay, 0.2145, wait, no, 0.2142857114.
Okay.
Yeah.
Eli,
Now,
you got your Q's and
If you see this, I hope it would be fairly easy for you to see which one is smaller and which one is larger. Okay? So if we look here right after the decimal, okay, Eli, you are being really disrespectful to the rest of the people in here. You're thinking like you're here all alone by yourself. No, listen to me. You need to make sure that you aren't interrupting whatever everybody else is thinking every time you've got a thought. Okay, so back off and keep a lot more quiet than you are. If we look at these now right after the decimal, we've got a couple like 0.6, 0.25. We get two equivalent ones here, a 0.5625 and a 0.2143. So if we were going to organize these from smallest to largest, would you be able to go back to our original decimals now and place them? Which one would be the smallest one here? Riley?
3/14.
Very good. So that's our smallest one, so we'd use that one. What's our next smallest one, Jade? Okay, good. So we've got 2/8, 1/4. And so if we just kind of lump those together to show they're right on top of each other, right, in terms of smallest to greatest, these equal each other. And so what would our next one be, right, if we cancel these off? Our next largest is what? Cool? Pardon me? Is this one smaller than this one? This one looks bigger, it's a lot of numbers, but it's 0.56, right? So I think our next one here is our 9/16, and then our last one is our 3/5. So when you convert it to a decimal, it's easy for us to compare the size of them. And if you do these questions, you'll get used to fractions. You'll be able to kind of just get a sense for them, which one is larger. A lot of people do this when they go shopping. What's my best buy? As you're looking at different stores, as you're price comparing, if you're going to buy like, 3/4 of a pound of cheese, and in one store it's $2.50, and another store it's $4, and you do price comparison, if you're good with numbers, it's going to save you a lot of money as you're shopping. Okay, so there's a lot of different reasons to keep up on this. So know method number 2 and number 1, common denominator or convert to decimal form. Eli?
Why do stores, like you were talking about, like the deals and stuff, why do they always says you can find a price lower than ours, we'll match it?
Yeah. Price match.
Wouldn't you just like go
That's
on
fine.
eBay, because they always sell things for like a cent? You
No,
need to have a receipt.
you need to have a flyer for it.
Yeah, it usually has to be an advertised thing in a store. There's usually some fine print to that. But a lot of stores want to stay competitive, and they want to stay competitive to people who are price shopping.
I know,
And with the internet these days, a lot more people do
Don't, like,
price shop.
why wouldn't you just go to a store that's lower? Why would you have to have proof and then go to that store.
Well, a lot of people want your service. They want your, right? So if a store is gonna sell something for $10, you could probably bet the store is gonna make $3 or $4 on that sale. Now, if you could say, hey, I could go over to shop B and buy it for $6, they're gonna say, well, we'll sell it to you for that price too. We'll match the lowest price out there because they want your business. They want you to just kind of go there then, thinking they offer very competitive prices. That's probably the best price in town because they say they'll be the lowest one. So if you can find a lower one, they'll say, we'll match it. We might not be the lowest on all the days, but if you can find a lower one, we want you to keep coming here and we'll match it. It's a business ploy that usually attracts more customers.
I
So,
guess, because then they don't have to go anywhere else.
yeah.
Yeah, that makes
And
me
you-
feel better about themselves when,
After,
like, feel like they're getting it from the
How
exact
do
same
they
price.
feel better?
Yeah. you want
People are weird.
the best deal, Eli. People don't feel feel like they're getting ripped off.
How did that convert to old people?
Cause they're weird.
Eli, often, I mean, Carson's right, often a lot of older people
Oh, weird.
have lived in tougher times, and a lot of them are more concerned about watching their spending. A lot of young people spend, it's fairly typical, spend pretty freely. They have a little less value on their money than a lot of older people do. So I think you're right, Carson, as you work quite a bit in retail, right? Both at Rona back in the day, I think, and now at Canadian Tire. So you've probably seen a lot of those kind of patterns, and I think that's probably pretty true. Young people have very different spending habits than older people do. So
Okay, why do every person like that's like lived back in the like 60s or 70s, they're like, you know, Sonny, I bought my car for 1 cent.
Dude, my dad bought a Camaro, 69 Camaro for $500.
Every old person says that. It's like, I bought this car for 1 cent. It's so
Okay.
annoying.
back to here. One other aspect of 2.1 is you need to be able to find a rational number between two other rational numbers. So here, those people that I gave a set of notes to, could you pay attention here? Because I'm going to add one more example to those notes that I didn't have before. If we had two rational numbers, such as 3/5 and 4/5, how could can you think of a way that we could squeeze a number between here? Because I think if you realize on a number line, if we had 3/5 on one spot, and then a little farther down we had 4/5 on our number line, without me drawing the whole number line out, there is a lot of options between here. But how can we write a fraction right between here? What might be a technique? Some of you maybe see a way through this before I start, or what's a technique we could do to get a fraction between the 3 and the 4? You can't put a decimal in a fraction, so you can't go like 3.2 over 5. Even though that is between, you can't mix both decimal form and fraction form. So that's not an option, even though it is true between. Carson? Sure. Zach? Okay, and that's where I want to go to next. But first, in fraction form, we could convert it to decimal form and then do this. Let's do that now. Okay? If we convert it to decimal form, you get used to easy fractions. When it's over 5, this is 0.6, and this is 0.8. As a teacher especially, we're always converting from marks on a test to percentage. We go to decimal and then multiply by 100, right? So teachers, I think, practice this, especially around report cards. What are your percentages? How are your marks? So what's the number now, Zach? Now it's pretty easy, I think, right? What's the number between 0.6 and 0.8? Pardon? Okay, so 0.7, right? Would fit right in there. Okay, also 0.65, a little bigger than 0.6, and smaller than 0.8. So it's pretty easy, I think, in decimal form to find one. So that's a good option. But in math is all about more options. You guys still want a little time to write that down or something? Okay. So converting to decimal form, I'll just write that right out as an option. Convert
Is that much? Can you program pinball on it?
Eli, can you hear yourself? Okay, come on.
My calculator.
That's apparently $120 and more.
Can you give it back to him right now?
He said I could borrow it.
Eli, come on, man. Okay, we want to look at that again. How about 3/5 and 4/5 if we don't convert to decimal form? Does anyone know another strategy? Yeah?
Go like 6/10, 8/10.
Excellent. Make it over a larger denominator. Spread these out. It doesn't look like we can fit anything between 3 and 4. I mean, they're right next to each other. But watch what happens if we go to a larger decimal, an equivalent fraction that's larger. And I won't explain that all again, but if we go to 6/10 and 8/10, then it's fairly easy again to see that 7/10 is right between there.
That's weird.
Okay, so if we make it a larger equivalent fraction, it's the same value. We haven't changed where it is on the number line. It's the same value, and we've snuck a number right between there. So that's good thinking, Zach.
That's number 8.
Now look back here. If we convert these to decimals, 6/10, that's 0.6, right? 6 in the 10th slot, and 0.8. And in fraction form, we've done just what we did in decimal form. Okay, let's get to an assignment. The board's kind of choking here a little bit. Okay, so 2.1 assignment. We've got December 3 here. For C, I'd like you to do questions 4 to 17, A and C, page 51 and 52. So those are just kind of the straight up fraction skills. To get a B, I'd like you to do the C. Actually, I'll write it a little differently so it's less confusing. I'd like you to do questions 18 to 26 and C questions. And to get an A, I'd like you to do a bunch of those questions that maybe you haven't done much in math in other years. I want you to try those harder ones. Questions 28 to 30. And C and D. And this is on 51 to 54. Okay. Now, I'd like to just point out a bunch of things. Here, if you look at how much time this took, it took almost 34 minutes. Now, that's why I like to post this. I've already posted this lecture on YouTube already. I've given this to an empty room a couple days ago. I posted it. I would think that for a lot of you, as you followed through this with me, a lot of this skills was review. Okay? If you think about it, did I really show you anything new?
No.
A lot of this was review, especially in this class. And that's why I wanted to post these things to YouTube. If you were to flip through YouTube and move through these examples and say, I can do all that, and right away you could just start on the assignment. Here, I've taken up 35 of your minutes of class time to explain. Now, for some of you who math hasn't been a real strong point for you before. This is valuable review. And I will keep doing this. But those of you that want to get ahead and use these 35 minutes so you don't have 35 minutes of homework, you could use this time to work on the assignment. You could know the assignment before class starts. I'm going to keep trying to be 2 days ahead on YouTube. If you come to class with some notes on that YouTube lecture, you could take your notes and rather than sit here during this time and hear this lecture over again, you can go sit over there and you can work on the assignment and you can save yourself that half an hour because these lectures take about a half an hour. I can't do it tighter without losing many of you. So they take about a half an hour to explain and answer your questions and share a few stories to make it come alive. But if some of you, who this comes easy to, and you want to avoid that half an hour of homework, that was the idea of a flipped classroom. You listen to it at home, get the idea, and then come work on the questions here in class. I'm going to do this still as a main method of instruction, and I think a lot of you benefited from this. You were thinking through thoughts, you're thinking, yeah, that's true, yeah, that's true, I heard that before, oh yeah, that's true. And it'll keep it straight, but I want to give you choice. If you like the YouTube option, come with some notes. You can't just say, I got the assignment, I want to work over there, I want to see some evidence that you have some notes, you looked at the video, and you paid attention to it, because I think there are valuable hints in there that would hurt you if you don't get. But I want you to have that option. So now we have the rest of the class until 11:37 because there's no assessment today. We're just starting chapter 2. You've got the rest of the class to work on this assignment. I'd encourage you to think about what you learned in chapter 3, last chapter. Some of you got behind right away. Stay caught up. For some of you that find C level easy, please push yourself a little bit. My daughter Lindsay's going to Prince Rupert this weekend to write her SAT test. There's 800 points on math on that test. The test is at a 2,400 total. 800 for math, 800 for science, and 800 for languages, English, communication, writing and reading. If she can score over 2,000 on that test, she'll be very eligible to make it to an Ivy League school.
What's that?
Some of the best universities in the world.
I thought Harvard
Now,
was.
Harvard is the best, recognized usually, but there's people that, sometimes it's Princeton, on some scale. If you get over 2,000 on that SAT test, you will be eligible for probably $8,000 to $10,000 in scholarships from American universities.
Can I take that money
Okay.
as ski?
Now, my daughter Jessica scored really well on that SAT test,
What did she get?
and in addition to her whole experience package, she had a lot of cool world experiences in our travels in Europe. And based on her high score and her good resume, she got accepted to Harvard. Now, she knows several people at Harvard who she met before from Vancouver area. She went to provincials in badminton. There were a couple of the Asian badminton players that were there who are also got accepted to Harvard. There are several Canadian hockey players that got accepted to Harvard because Harvard wants people who take an idea, who take a passion, somebody, and take it to the top. They want people who have done cool, world-class things. And I would encourage you, as you do these assignments, push yourself. You don't need to set a top university as a goal, but keep making yourself a little bit better. Please don't settle for second best.
So, Mr. Ewell,
You have choice in this system based on your level and your ability, but please keep pushing yourself. Don't just settle for a C, push for a B. And a B comes pretty easy, well, push for an A. And push means maybe some frustration and tears once in a while. I brought up Lindsay because she had a teacher in Ukraine who pushed her hard. Several nights of tears while we sat there and I helped her with her math and stuff. But just this morning she was saying, man, I took that practice SAT test and I got 3 wrong.
what?
If she can get 3 wrong on that SAT test, now she thought that was an easier version of it. You know, there's you never take the same test twice. She thought it was easier than before, but she thank right away her math teacher in Ukraine who gave her 50 to 75 problems of practice a lesson. And he demanded that it was done. And so she worked hard at it, but now she feels she doesn't just have the knowledge, she also has the skills. You might be able to bounce a basketball, but can you bounce a basketball in a crowd? Can you bounce it with your left hand and right hand? Can you bounce it on the full run? Can you bounce it through a crowd and do a layup?
Yep.
The skill part is, can your body do, just because you know it, can you do it? Math is interesting. It's both knowledge and skills. Skills take practice. So please practice.
Mr.